For experiment 5 in Power Electronics Laboratory, this is entitled Half-Wave Rectifier Circuit with RC Load. The objectives of this experiment is to simulate the half-wave rectifier with RC load using PSpice software, to utilize the software to observe the behavior of half-wave rectifier with RC load, and to determine various quantities using PSpice software. So for the procedure, the first part is to make the RC load circuit. So this is the circuit. To do that, we need to open the OrCAD PSpice app. In the application, we should click on New Project, Experiment 5 for the project name. Click OK, create a blank project, OK. And here we're going to make the circuit, this circuit, with these parameters and the simulation setting and the maximum time step and the transient analysis should be performed. So let's make the circuit. Place component, PSpice component, source, voltage, sign, and place another component, the diode, here diode, and capacitor, resistor. Change the values. Zero. This is 311.27. This is 0, 60, and AC is 0. Connect the circuit in series, and the resistor is in parallel with the entire circuit, with the capacitor rather, and connect a ground. Next, in the simulation profile, name it experiment 5. This pop-up window should appear, and change the runtime to 16.67 milliseconds and the maximum time step to 10 milliseconds. Click apply and then OK. After that, need to find the table for the results for table 1. These. So to do that, click on play. But first, let's add a voltage probe here. Play. So this is the output voltage waveform. Let's add trace. We're going to add V1 plus. So to get the angle, click on plot, axis settings, axis variable, click on axis variable. And in the trace expression, type time times 60 times 360. This is for us to get the angle. Click OK. So here, as you can see, we can zoom in for the intersection right here. So navigating through the application, we can check for the angle of intersection, which is around here. So to check that, cursor on, and navigating through the simulation of the waveform, we can observe to have a value of wait, let me just adjust it. At its maximum here, we can observe value of 101.023 degrees, which is the angle. So for the VO maximum, we added a trace of VR1, and we're going to navigate through the peak of the waveform. As you can see here, the value is 309.063 and 170.276. This is the VO minimum. Next, we're going to add the trace expression for the average VO. So to do that, add trace, um, click on average AVG, and um, VR1. Here, we're going to um, uh, turn cursor on, and at the very end, this is the average, which is 224.923. For the peak diode current, let's remove this trace, add another trace, click on this one, ID1, and here we should navigate the simulation or the application. We should zoom the waveform. Uh, Here I already zoomed it and turned the cursor on. So to get the peak, just right about here, put your cursor, and you can see a value of 11.707. There. Next, we should measure the peak capacitor current. So add trace, this one, C1 for the capacitor. And just like for the diode, we're going to turn cursor on, and here, navigate the cursor just about here, and we're going to have a value of 11.753. For the next part of the experiment, table 2, these are the values that we're going to get. The ID average, IC RMS, IR average, PS, and PD. So let's run the PSpice and add trace, delete this from our previews. Add trace, AVG, and ID1, just like in the probe expression in the experiment. It is already given. So to measure it, turn cursor on, and at the very end of the waveform, we'll see a value of 2.1640. This is the average current in D1. Next, uh, we're going to add another trace. This is for the RMS in IC. There, click OK. For the RMS, turn on the cursor, and also at the very end of the waveform, we'll get the value of 4.2949. Next is we're going to get the average power in R1. So to do that, click on AVG and WR1. There, this is the waveform for the for R1. So turn the cursor on. At the very end, we'll get the value of 272.535 watts. This is the average power in the resistor. Next, for the power on the voltage source, we're going to add trace, AVG, not that, this one, and WB1. There. Click OK. The same step, cursor on at the very end of the waveform, negative 363.818 watts. Lastly, the power average power in the diode, add trace, AVG, and WT1 here. Click OK, cursor on, and there. 3.9957. And there. We're done getting the values for table 1 and table 2. So the next is a summary of all the accumulated values.